Okay. Mukhang okay naman. Kaso, ito na naman yung nagzo-zoom effect na naman si TikTok. Yun, I think okay na siguro ito. Ayan, nagzo-zoom effect na naman siya. Ano ba pigilan yung zoom effect nitong TikTok na to? Wala na nga. Nawala ako sa mode dito sa e-secure ng government app natin. Na-prostrate ako. Inang verification yan. Grabe. Na-block ako. Okay, I think it's okay na siguro yung aking sounds and okay naman yung microphone ko. Two authors and work were writing. I think I don't need to read this book. Read these pages. What happens when there are no best practices? Why does technologies like a software could present at a conference or write book? Because they have discovered what is colloquially known as a term so overused that those who speak it exclusively experience backlash regardless of the term. Technologies write books when they have figured out a novel solution, a general problem, and want to broadcast to a wider audience. Ano ba to? I think let's have a 30 minutes timer. But what happens to the vast set of problems that have no good solutions? Entire class of problems exists in software architecture that have no general solution rather than present one messy trade-off against an almost equal messy set. So for developers build outstanding skills in searching online for solutions to a current problem. For example, they need to figure out how to configure a particular tool in their environment. Expert use of Google finds the answer. But that's not true for architects. For architects, many problems present unique challenges because they conflict the exact environment and circumstances of your organization. What are the chances that someone has encountered exactly this scenario and plugged it or posted it on Stack Overflow? Stack Overflow, still Stack Overflow. I think this book is, I guess, made pre-AI era. Architects may have wondered why so few exist about architecture compared to technical topics like frameworks, API, and so on. Architects rarely experience common problems but constantly struggle with decision making in novel situations. For architects, every problem is a snowflakes. In many cases, the problem is novel not just within a particular station but rather throughout the world. No books or conference session exist for those problems. Parang konti lang yung I tried to check some webinars for software architects. Actually, I cannot find one. Architects shouldn't constantly seek out silver-bullet solutions to their problems. They are rare now, as in 1986 when Fred Brooks coined the term. There's no single development, either technology or management technique, which itself promises even one order of magnitude tenfold improvement within a decade in productivity and reliability and simplicity. Because virtually every problem presents novel challenges, the real job of an architect lies in their ability to objectively define and assess the set of trade-offs on their side of consequential decision to resolve. More on ano lang to. Prelude lang to. Parang it's kinda warming up my mind. Kinda it's just aligning my mindset. Until what page? Okay, page 9. Don't try to find the best design in software architecture. Instead, strive for the least worst combination of trade-offs. Actually, this one, after I read the first book, the fundamental books, this is now my mindset for architecting. Least worst combination of trade-offs or best possible solution. Often the best design an architect can create is at least worst collection of trade-offs. A single architecture characteristics exists as it would alone, but a balance of all competing architecture characteristics promote project success. Hard part is the title big double duty. First hand connotes difficult, and architects constantly face difficult problems that literally and figuratively no one has faced before, involving numerous technology decisions with long-term implications layered on top. Solidity just as the grabe naman. Change much less because similarly, architects discuss the distinction between architecture and design, where the former is structural and the latter is more easily changed. Thus, in this book, we talk about the foundation parts of an architecture. Definition of software architecture itself has provided many hours of non-productive conversation among practitioners. One favorite tongue-in-check definition is that software architecture is the stuff that's hard to change later. The stuff is what our book is about. Giving timeless advice about software architecture, the software development ecosystem constantly and chaotically shifts and grows. Topics that were all the rage a few years ago have either been subsumed by the ecosystem and disappeared or replaced by something different or better. architecture or larger mass orchestration-driven service-oriented architecture. Now, virtually no one builds in that architecture anymore. For reason we'll uncover all the along the way. The current favored style for many distributed is microservices. How and why did the transition happen? When architects look at particular style, especially in historical, they must consider constraints. Open source wasn't a viable option, often for political rather than technical reasons. For a larger companies, thus architect emphasized shared resource and centralized orchestration as a solution. However, in the intervening years, open source and Linux became viable alternatives, making OS commercially free. However, the real tipping point occurred when Linux became operationally free with the advent of tools like Puppet and Chef, which allowed development teams to pragmatically spin up their environments as part of automated builds. Once the capability arrived, it fostered an architectural revolution with microservices and the quickly emerging the infrastructure of containers and orchestration tools like Kubernetes. This illustrates that software development ecosystem expands and evolves. It unexpectedly creates new capabilities or I think this just history. I think I need to move this camera a little bit to the left. There you go. Yeah, just there you go. Data is precious thing and it will last longer than the system themselves. True. For many in architecture, data is everything. Every enterprise building system must deal with data. It tends to live much longer than system or architecture, requiring diligent thought and design. However, many of the instinct of data architects to build technical systems create conflicts with modern distributed architectures. For example, architects and DBAs must ensure that data survives the breaking part of monolith system and that business can still derive value from its data regardless of architecture undulations. Yeah, what is undulations? This is new to me. Is a continuous smooth wave-like motion or waveform derived from that? A continuous smooth wave-like motion or a waveform curve or outline. Okay. This is my first time hearing or seeing this word. Said in most important asset in a company, businesses want to extract value from the data that they have and are finding ways to deploy data in decision making. Every part of the enterprise is now data driven, from servicing assisting customers to acquiring new customers, increasing customer retention, improving products, predicting sales and other trends. This reliance on data means that all software architecture is in the service of data, ensuring the right data is available and usable by all parts of the enterprise. The authors built many distribution systems a few decades ago when they first became popular. Yet decision making in modern microservices seems more difficult, and we wanted to figure out why. We eventually realized back in the early days of distributed architecture, we mostly still persisted data in a single relational database. I think until now naman. However, in microservices and the philosophical adherence to a bounded context from domain-driven A way of limiting the scope of implementation data coupling data has moved to an architecture concern. Along with transactionality, many of the hard parts of modern architecture derive from tensions between data and architectural concerns. Online transaction. OLTP, online transaction processing. Ethical data used by data scientists and other business analysts for predicting, trending, and business intelligence. This data is typical, not transactional, and often not relational. It may be in a graph database or snapshots in a different format than its original transaction form. This data isn't critical for the day-to-day operations rather than for long-term strategic direction and decisions. Architecture decisions records, ADR. Okay. Hindi ko na napapractice tong part na to. I haven't practiced this. One of the most effective ways of documenting architecture decision is through ADR. ADR was first evangelized by Marker Nygaard in a blog post, and later Mark adopted in the ThoughtWorks technology radar. An ADR consists of a short text, usually 1 to 2 pages, describing a specific architecture decisions. While ADRs can be written using plain text, which they are usually written in some sort of text document like format like ASCII doc or Markdown. An ADR can also be written using wiki page template. We devoted the entire chapter of ADRs in our previous book, Fundamentals. Yeah. Although, saglit lang to. We will leveraging ADR as a way of documenting various architecture decisions made throughout the book. Oh, okay. So I can finally now practice it. To be honest, it's kind of hard to make an ADR. A proper ADR with proper way of putting details on it. For each architecture decision, we will be using the following ADR format: context, decision, consequences. I think context is the description of what we're going to do, and then decision, what are discussed in the actual discussion. I mean the final action. Right? Consequences. If we do this, what will be the consequence, or what will be the effect on the architecture? So this one is more on the trade-off. I mean, this one is describing the trade-offs, the consequences. Oh wow, 15 minutes na pala agad ako. And this one, fitness function. One of those things that I don't really understand here in the first book. Once an architect has identified the relationship between components and codified that into a design, how can they make sure that implementers adhere to the design? More broadly, how can architects ensure that the design principles they define become reality? They are the ones to implement them. The close questions fall under the heading of architecture governance, which applies to any organized oversight of one or more aspect of software development. As this book primarily covers architecture structure, we cover how to automate design and quality principles by a fitness function in many places. I need this. This is the topic that I really want. Software development has slowly evolved over time to adapt unique engineering practices. In the early days of software development, a manufacturing metaphor was commonly applied to software practices, both in large, like the waterfall development process, and a small integration practice or projects. In the early 90s, Thinking of development engineering practices led by Kent Beck and the other engineers on the C3 environment called Extreme Programming Exp. Thousands of same lessons were applied to the intersection of software development and operations, spawning the new role of DevOps and automating many primarily manual operation chores. As default, automation work allows teams to go faster because they don't have to worry about things breaking without good feedback. Thus, automation feedback have become central tenets for effective software development. Consider the environment and situation that led to breakthroughs in automation. In the era before continuous integration, most software projects include a lengthy integration phase. Each developer was expected to work in some level of isolation, rather than integrate all the code at the end of the integration phase. Vestige. What is vestige? What is... What's the meaning of vestige? Remnants, something like remnants, right? Okay, like remnants of this practice linger in version control tools that forces branching and prevent continuous integration. But a strong correlation exists between product size and the pain of the integration phase. By pioneering continuous integration and the XP10 DevOps revolution followed as similar as Linux and open source software became good enough for enterprise. In both cases, in technology insights led to automating recurring job that was handled by expensive role. It uses particular architecture style for communication and how they can make sure that a developer implement it correctly. When done manually, architect perform code review or perhaps hold architecture review board. The architect talk about the elasticity. It's the ability of the application to withstand a sudden burst of users. Also that the architect doesn't need to know any details about the domain. It could be an e-commerce site, an online game, or something else. Thus elasticity is in an architectural concern. To maintain good internal structure integrity at the code is however malevolent forces organism. Coding in popular Java or .NET development, as soon as developer reference class not already imported, the ADD helpfully present a dialog asking the developer if they would like to auto-import the reference. However, arbitrary importing classes or components among another spell disaster for modularity. For example, illustrates a particular damaging anti-pattern architects aspire to avoid. Cyclic dependencies to. In this anti-pattern, each component represents something in the others, having network of components such as damages modularity. Because a developer cannot reuse a single component without auto-bringing the other along, and of course, of other components are coupled to other components, the architecture tends and more toward big ball mod anti-pattern. How can architect govern this behavior without constantly looking over the shoulders of trigger-happy developers? Okay, trigger-happy. Code reviews helps but happen too late in the development cycle to effect. If an architect allows development team to rapidly import across code base for a week until the code review, serious damage has already occurred in the code base. Write a business function to avoid component cycles. Okay. In the code, an architect uses the metric called JDepend to check the dependencies between packages and the two instance structure. This is the rich example of business function guarding the important rather than urgent processes of work is an important concern to architect. It has a little impact on day-to-day coding. Shows a very low-level code-centric business function made popular code hygiene tools such as SonarQube. Implement many common business function in a turnkey manner. However, architects may also want to validate macro structure of the architecture as well as the micro. When designing layer architecture such as integer 1-2, the architect defines the layer to ensure. Okay. Presentation controller service persistence. However, how can the layered architecture How can the architect ensure that developers will respect those layers? Some developers may not understand the importance of the pattern, while others may adopt a better to ask for investment permission attitude because of some overriding local concern, such as performance, but allowing implementer to erode the reasons for the architecture hurts the long-term health of the architecture. Example, the architect defines the desirable relationship between layers and writes verification fitness function to govern it. This allows an architect to establish principles outside the diagram and the I think I'm already past with the uploaded pages. Oh wow, this prelude is somehow long. Okay. complex data mesh like the architecture governance. Machine that form a cabal or restrict to an ivory tower to build an impossible complex interlocking set of fitness function that merely frustrates the developers and team. Instead, it's a way for architect to build an executable checklist of importance but not urgent principles of software. Many projects drown in urgency, allowing some important principles to slip by the side. This is the frequent cause of technical debt. We know that this is bad, but we'll come back to fix later, and later never comes. By quantifying rules about code quality, structure, and safeguards against decay into fitness function that run continually, architect built a quality checklist that developers can skip. A few years ago, the excellent book, The Checklist Manifesto by Atul Gawande Picador, highlighted the use of checklists by professionals like surgeons, airline pilots, and those other fields who commonly use, sometimes by force of law, checklists as part of their job. It isn't because they don't know their job or are particularly forgetful when professionals perform the same task over and over. It becomes easy to fool themselves when it's accidentally skipped and checklists prevent that. Fitness function presents a checklist of important principles defined by architect and run as part of the build to make sure developers don't accidentally or purposely because of external forces like schedule pressure. We utilize fitness function throughout the book when an opportunity arises to illustrate governing an architectural solution as well as initial designs. Baka magpo-focus yung some of the topics here to fitness function. Yeah. So I need to take a break at least 5 minutes. Yes, of architecture, a fitness function is an automated or semi-automated check that tests whether your system is still meeting an architectural goal. For a RAS app, it means you define the measures like this app should remain fast, safe, modular, and observable, and dependency controlled. Then you turn those rules into checks in your development work. Simple example. Suppose you are building a RAS UDP server. Your architectural goals might be correctness, cargo test must fast B, Code quality, clippy, D1 must pass, formatting, okay, security, cargo audit must not report critical vulnerabilities, performance, packet parsing, benchmark must stay under a threshold, memory safety, no unsafe allowed unless explicitly approved, modular, so this is the goal, okay, so somehow this is my checklist. Build health app must compile on Linux. I think let's move this one to a project. Unless common fitness function look like this. Let's valid one. This fitness function for correctness. This is a fitness function for correctness. Correctness fitness function, cargo test. Format fitness function, cargo FMT. The code will follow consistent style. Useful for things because formatting should not be debated in code review. Okay. This checks, for example, Clippy can detect unnecessary clones, inefficient patterns, suspicious logic, and style issues. Dependency fitness function, cargo audit, deny check. You can use deny check. No duplicate create versions, only approve licenses, no ban creates, vulnerability check. The RAS app must be controlled and performance fitness function. RAS app often care about performance. You can create benchmarks. Okay. Architecture boundary fitness function. This is where fitness function become more architecture. Example. You may want this packet parser must not depend on storage. Why? Because the parser should only parse bytes. It should only know about serial DB, Postgres, Redis, or any. A fitness function could inspect cargo pass and fail it if the dependency is added. The parser should only stay independent. RAS allows unsafe, but you may want to control it. You can deny code globally. This is a fitness function for memory safety discipline, or it can allow unsafe in specific rates. Observability for production RAS of memory core structure logs or tracing. In RAS app exposes an HTML, you may want OpenAI must not break without approval or snapshot testing. Cross-platform fitness function. Since you build RAS project for Linux, macOS, and Windows, this very CI fitness function could run. Okay. This means every change is automatically tested against your quality rules. A very good specific fitness function for your packet parser would be given a known byte sequence. The parser must always decode the same latitude and longitude that protects your protocol from accidental breaking changes. Simple mental model. A normal test asks, does this function work? A fitness function, is the system still fit for the architecture we want? Those are ways to implement fitness function for your app. Okay. So, ganyan lang pala siya. I think I'll try to read this one. Chapter 1 topic. There are no backlist on it. One of the central ideas of this book is that software architecture rarely has universal correct answers. Developers often solve problems where unknown solution. How do I configure it? Okay. Problems are different. Uniqueness, business concept, organization, battery, structure, budget limitation, existing systems, future uncertainty. Because every environment is different, the same architecture decision may be excellent in one company and terrible in another. Therefore, architects shouldn't search for the best solution. They should search for the least harmful set of trade-offs. A solution that is generally considered optimal. The author's challenge is the idea for architecture because architecture decisions are highly conceptual. Improving one thing often worse another. Example, more complexity, reduce visibility, more operational overhead, less maintainability. Novel problems that are unique enough that Google may not have the answer, nor is the purpose. This is where architects spend so much. The book suggests that architecture problems are often unique. Every organization has different constraints, priorities, and risks, making each architecture problem on a snowflake. Why this matters in software architecture? This is really the most important mindset shift in the entire book. Many engineers approach what is the right answer, which compromises is this damaging. That shifts depend how decisions are made. Architect becomes less concerned with perfection and more concerned with balancing competing forces. Imagine you're designing internal problem. Monolith, easier deployment, simple debugging, lower operational cost, less the independent scaling, larger code base. Microservice independent deployment, independent scaling, cons distributed system complexity, more operational burden, more network failures. Which is the best architecture? The answer is neither. The answer depends on team maturity, budget scale, business goals, deployment frequency. They're exactly the type of reasoning the other authors are encouraging. Okay. Parang ano lang. Part 1 lang. Mistakes. Microservices are always better. No. Microservices solve specific problem, introduce new ones. Architecture books contains the right answers. Most architecture books provides techniques, patterns, and trade-offs. You still need to decide. True. Architects should maximize every quality attribute. Impossible. You cannot simultaneously maximize performance, security, scalability, simplicity, cost efficiency. Improving one usually impacts another. Let's say security. Sometimes if you're really putting a lot of validation, sometimes the performance suffers. Let's say cryptography. Memorable quote from this topic. Don't seek the best design, seek the least worst combination of trade-offs. This idea, repeatedly throughout the book, I think I need to have a portion in the system prompt that allows me to have more discussion. Yeah, I think this is much better. So before the quizzes, the system will ask if there is something that needs to be discussed. Ah, nice one. Okay, this is good. So before the quizzes, we add. Okay, so here. Oh, I think I need to end the stream because it's already late. Okay, I guess that's